I was just reading about MRIs. Hey, Val. That apparently they use 2,000 liters of helium and it's in short supply. All right, so it is officially noon SLT time, and I'll just give a bit of background. These lab experiments were developed for the University of Hong Kong. They contacted me in 2020, right at the height of the pandemic, right when we all suddenly had to stay home. I got this email that apparently my name had come up. They were trying to develop a way to enable their pharmaceutical students to do their chemistry labs remotely, since they weren't allowed to go to the university and do face-to-face education. So they contacted me because my name came up, and somebody that I had used Second Life in some of my courses when I was teaching there, when I was living in Hong Kong. And they specifically wanted to study surface chemistry experiments. In particular, we focused on capillary rise and drop weight. Now, these were designed to support two users at the same time who could log in. And since it's 4 or 5 years ago since I played with this, I've kind of forgotten how the user 2 logged in. But it was designed that you could get both names up there. You can see on the left top part of the board where it says Mr. K. Kaz as user 1, because I clicked to open up Capillary Rise, so I'm logged in. And when I complete these experiments, it'll send an email with my avatar name to the instructor of the course. The lead-in for this education, for these in-world experiments, was set up in a Moodle course. That's the LMS at the University of Hong Kong. And so it would give a link so the students could go in here, and it would supply some background about, what are these experiments going to be doing and what they're used for, and also quiz questions were embedded in Moodle to follow up with these. So I clicked on Capillary Rise, and you can see I have 3 different experiments. So I'll click on Part 1A. And for those of you that are pretty good with your camera controls, you can look down underground, and you can see that we stashed the board, the prior board, down below the lab bench. So it's just hidden away. Pretty low tech, but sometimes that's less problematic. So now 5 beakers appear, 1, 2, 3, 4, 5 different colors, and you can see on the left side, the first one's dichloromethane, and then the second one's methanol, pyridine, human blood, a whole gallon of human blood apparently, and glycerol, each with its own beaker and its own color. And you can see on the right side of the board, it has 3 quantities that are defined as density, grams per cm to the -3, rise level in centimeters, and they want us to focus on surface tension. So these experiments were designed to illustrate for the students and so they could get hands-on practice in calculating surface tension of various fluids. So you'll notice, if you use your camera there, this was the first take. It's and we put the little prompt there, touch any beaker to see results. And then later in the drop weight, you'll see that we slanted those at an angle so they were a little easier to see, because these are really designed for the people to stand very close to the lab bench. But obviously that might block the view for others. But and I would set up 6 or 7 or 8 of these, and they would be operated in pairs of students. So if you touch any beaker to see results, I touch the first beaker, and you can see that the liquid rises up the tube, and then it's showed as 1.62 centimeters for the rise level. Beaker 2, and methanol lights up, and the fluid rises up the capillary tube. And over there on the right side, you'll notice that it changes. It shows the density of the liquid, and the rise level is 2.24 centimeters. Now we're exaggerating here a bit to make it easier to see. And then you'll notice that surface tension is highlighted, and it's being calculated based on the rise level and the supplied density of the liquid. So we continue along. Here's the third beaker. I just touched it by clicking on it, obviously. And 3.30. And the human blood, my favorite, goes up 4.14, and then number 5, finally, 3.92. So another factor they asked me to build into these, I'm the systems analyst, and I also designed the basic interface, and then I worked with a developer who coded this. And the idea here was to show the rise and fall based on the different rise levels. So different liquids rise up to different degrees, and using the same size tube for all of these liquids. And that's kind of the introduction to calculating surface tension. Yeah, probably something to do, viscosity perhaps related to density. Phil, would you say?
Yeah, here I'm rusty on this stuff, so but it's just intuitive.
No, I agree.
Thought, glycerol is kind of viscous, I think.
Yeah, and I imagine that.
I think glycerine. I'm not.
Yeah, I imagine that each of these liquids has a different viscosity, and that results in different rise levels. Okay, any questions about this so far? I'll just run through the various experiments, and let me know if you if you can't hear something or you want me to expand on some particular area. All right. So, and also notice you can remove user 1 and remove user 2. Oh, would somebody like to try clicking where it says user 2, touch this space to add yourself to the lab? Yeah, and it put up a Sheila Yoshikawa wants to come in, so I give her permission. I'm glad I remembered that. I was just playing that with Stevie and I couldn't remember the process. So now you can see Sheila Yoshikawa is enrolled in the experiment, and she can click on these things too. So now I'm going to pull back a little bit, and I can reset the lab. And then now she could click on any one of these. Sheila, if you could click on one of those beakers, those colored beakers. There you go. So she can also enable the experiments and work the way through. Oh, another feature was that all of the results are plus or minus 5%. So it's really not advantageous to copy the work that another student did, because that kind of reveals that you copied, because all these results, for example, surface tension of 0.0559, that's going to be unique to this particular experiment, since it's all varies up and down, much like reality. There's no perfect answer. It's going to be some variation. All right, so I'm going to quit out of that lab and step through into Capillary Rise Part 1B. Okay. So now you've got 3 liquid types. And again, you touch on a beaker to continue. And it comes up. And so now we've got the density and the rise level, and the yellow highlighted one that wants the students to calculate the surface tension based on the supplied equation. Does it record who the student is that gets a particular result? Yes, when it sends the email to the instructor, well, no, not particular results. It just says they completed these experiments. But you're right, that would probably be a good idea, to just dump all the data into an email if you really wanted to put pressure on the students. There you go. So Sheila stepped through to beaker 2. Thank you, Sheila, for leading the way while I blather on. You want to do isopropyl alcohol too? There she goes. So we figured it'd be easier and more comfortable for students to work in pairs, support each other and challenge each other, but not too big, not too many people in the groups where you have, slackers that don't do anything. So that's this one, where 1B, where now we're supposed to calculate by hand the surface tension for each of these 3 liquid types: water, ethanol, and isopropyl alcohol. Any questions so far? I'd like if the students had to indicate the units on the number. There you go, right? You got to know the units. And I think, I don't know, anybody know what the symbols are there for surface tension? Any of the chemistry people? Gamma, Newton meters? I don't remember. Any volunteers for what that equation, the symbols in that equation? Looks like a y, n over m. Well, the equations are also supplied in Moodle. Newton meters, yeah, that's kind of what I was thinking. And then I forget that it's a Greek symbol. I think from trying to remember 4 years ago, it was gamma. But I agree, they should know the right units. All right, moving on. Capillary rise part 2. All right, so same basic setup, but now we only have one liquid type, but 5 different containers. And you'll notice that again, we have rise level, but now it says inner diameter. So if you click on the first one, it drops in a tube where the diameter is 0.5 millimeters, and it goes up really high. And then on beaker number 2, also containing ethanol, it's a different inner diameter, only 0.4, and goes up even higher and higher yet. So 0.3 millimeters, 0.2 millimeters, and then 0.1 millimeters goes the highest. So we're trying to get the students to see the relationship between the diameter, the inner diameter of the tube, and the resulting rise level. All pretty basic, but as everybody's familiar with, the idea here is that no one's going to drop a glass beaker full of human blood on the floor. No one's going to get glass in their feet or their eye. No one's going to be disgusted by, is this real human blood kind of thing? Take it home, pour it on your roommate's head. I don't know, but you get the idea. Less trouble. There you go, safety, lab safety. And that is how I made my name at the University of Hong Kong, was developing lab safety simulations in Second Life, where you could go in and no matter what you did, eventually a terrible fire would break out and you had to decide what to do. And obviously the correct answer is to run out of the lab and hit the fire alarm. But the smaller fires, it did allow for trying to put it out with a fire blanket. Aren't they at risk of being very unsafe? Well, the idea, Sumo, is that they develop some familiarity. So at least they know what they're supposed to do. I think they're less likely, the theory is they're less likely to make mistakes. Also, you can let more undergraduate students have access to a lab, because every lab has to have a supervisor there. So you tend to have limited lab hours. And this enables a lot more undergraduate students to have access to simulated equipment. So, yeah, poisoning, chemical burns, that kind of thing. And you can simulate a huge fire and then click and it all goes back to no more fire. So hopefully they're familiar with following the directions. And, oh, yeah, Phil Youngblood pointed out there's Chemistry World. And by the way, Phil, if you could pass along that I'd be happy to contribute this these chemistry lab experiments to that Chemistry World if they're interested. So let's go into drop weight. And you got part 1, 2, and 3. And here's all the equipment that pops into being. And you've got 5 liquid types: hexane, ethanol, quinoline, glycerol, and water. And you've got a pipette radius, 2 millimeters, and it looks like you're trying to calculate surface tension. So here you can see that we figured out we should drop the prompt down to an angle so it's easier to read, because you can't expect all the students to be slick with their camera controls. And you left-click the conical flask, which is flashing around the base, you'll notice. So we tried to make this as intuitive and less necessary to have people there, helpful people, right? They can pretty much just intuitively find their way. So now it says left-click the pipette or pipette holder, and it's flashing over here on the right. And you click there, and it magically flies across to the beaker that I click, and sucks up a few drops. And then, after we built this very complex apparatus, the professor was like, well, maybe we should have just done a handheld beaker because there's a lot of steps to teaching the students how to manipulate these little squeezy vice things. And yeah, it's expensive to do all these things in Second Life with coding. So now it's squeezing, and you'll notice at the base of that conical little place there, it's counting up the number of drops. As you can see, the liquid building up in the base of the conical beaker. Now this is probably the most dependent on camera controls, but if your avatar is standing, bumping its waist against this lab bench, they could probably see it even without without camera controls. So now it's got 20 drops in there. So we're going to click to free the pipette. And here the developer just said, I'm going to have it run through automatically. I'm not going to back up through all those steps. And now the flashing arrow says, click there, and it flies through the air, and it never gets dropped and broken, and it sits on the scale, and it's 0.4774 grams. So that's pretty precise, but again, plus or minus 5%. So all of these measurements are going to have some variability in it, which is one of the key characteristics of inquiry-based learning. All right, so that was hexane. Could I get a volunteer from the studio audience? Let me see if I can remove myself. There. Okay, I removed myself. So who would like to volunteer to be user 1? Oh no, become user 2. Sheila was promoted to user 1, and now it's user 2. To touch this space to add yourself to the lab. Yes, can I get a volunteer? Thank you, Electra. She types really good for a panther. Come on now, don't be shy. Several of you have chemistry backgrounds. Okay, so Sheila, you need to click on accept to accept Dee Beaker. And now Dee Dee can take over because I suddenly became ill and had to leave the experiment. And now either one of you can do ethanol. So you left click on the conical flask, which is flashing. Oh, it's okay, Sheila. That's a good test if you have no chemistry background and yet you can puzzle your way through this experiment. So Dee Dee, you want to click on the flask that's flashing? If you hover over it, it says, actually it still says drop weight. Dee Dee, can you click on that flask? There you go. And she put it in place. And now you can see on the right, it's clicking that it wants you to click on the pipette or pipette holder. I did a lot of work with much fancier pipettes in previous biochemistry labs. Giant ones, we'd blow them up to 10 feet tall, and so students could get familiar with the way they work. Sheila or Dee Dee, click on the pipette. There you go. Up it goes. And now click on any beaker. Okay. So I think Sheila teleported onto the lab bench. All right, so click on one. I think it wants to do the third one. It wants you to click. All right, that's fine. All right. And then now you have to click on those flashing arrows that are on that stand. Yep, there's one. There's two. Yep. And this is how the students kind of simulate the idea of learning how to do the hands-on tactile controls on that pipette squeezer. Very precise way to get out 20 drops. So now you can see the liquid pouring down into the conical flask, 12, 13, 14, 15, up to 20. It never makes a mistake, right? It never accidentally squeezes in 21. And then she's going to undo it. Yep, there it goes. And click on the arrow. And there it flies over into the scale. No, and notice that it's very good scale. It's got glass enclosure, so the air conditioner doesn't blow on it and change the weight. That's the way it was explained to me. All right, so 0.6380 grams, and then click on that little arrow. All right, excellent. So anybody, do we need to continue on through this, or shall I move on to the next experiment? I think you guys get the idea. So you can reset the lab up there at top right. I don't think I can do it, actually. I think I'm dependent on you guys to click on quit lab. There you go. And then click on part 3. And you kind of have to click twice. One to say I'm working on that, and then, yeah, there you go. So if you have camera controls on, sometimes you get wrenched underground. All right, so now we have liquid type ethanol, and you touch a number to set the pipette radius. And then you can left click the conical flask to get started. So pick a pipette radius and then click on the flask. Yep, and it flies over. So it's the same basic procedure, which hopefully will kind of become second nature, right? Of course I go get the pipette, and of course I put in into the pipette squeezer. Oh no, it goes in it picks up the ethanol, and then it goes over. And the radius is locked, so it's going to focus on this particular pipette radius. And so the procedure should become second nature just through repetition. That, you know, of course I need to do this. This is what I always do next. And the students are recording these results in the Moodle LMS, and that's how all this experimental activity is captured in its exact results. And when you calculate the surface tension, that all gets stored in the Moodle quizzes, basically. So it's kind of interweaving between the Moodle LMS and the Second Life. I don't know if anybody can remember, what was it called? Sloodle? Anybody remember Sloodle? It was a mix between Moodle and Second Life quite a while back. And I thought about trying to use that, but then you have to get it all installed on the Moodle server, and I'd already gone through and fought many battles in the Faculty of Education just to get a experimental Moodle server where we could explore the latest plugins rather than go through the justification for Sloodle. So I just used their basic Moodle course, and I advised them on how to set up the quiz and everything. And now, Dee Dee or Sheila, if you click on, I think you need to click on the 1.0 millimeter. I think if you click there you go. So now it's we've selected a different pipette radius, and then you go, yep, on the beaker and back for the pipette. It flies over there, picks up some ethanol, enough for 20 drops, right? I'm sure that's happened where people don't pick up enough and they only get 18 drops. And they have to start over again. So they don't have to suffer through those mistakes. So the idea was to support surface chemistry education for pharmaceutical students, where they learn to calculate surface tension and the relationships between density, rise level, and I guess drop weight, along with to calculate density. And if anybody has a better input on that, somebody with a chemistry background, I double majored for my undergraduate, psychology and computer science, and then did a master's and an ed.d. in education. So not a whole lot of chemistry. I did chemistry 101 as a freshman, I think, in undergraduate. So luckily, what is that when they use content? TPAC. Has anybody ever heard of TPAC? Technology, pedagogy, and content knowledge. Does that strike a chord with anybody? Well, that's the basic idea when you get the right people together to work and develop a project like this. The Second Life, the virtual technology, the pedagogy comes from really me and also the professors in the medical faculty that actually do the chemistry training, and then the content knowledge is pretty much purely the professor as far as exactly what does he want done. And a lot of the technology then is supported by the developer, who did a beautiful job with all this simulated equipment. Yeah, thank you, Sheila. So let's see. I think if you, Sheila, click on remove user one, maybe. Yeah. And so now Sheila has dropped out, Dee Dee has been promoted to user one, and now anybody can click on user two where it says touch this space to add yourself to the lab. Any volunteer from the studio audience? Stevie, how long am I supposed to go on? Is it like a 30-minute thing or 45? Well, I need a lot more participation from the studio audience. Are some questions? There we go, Vic. Thank you. So now Vic is enrolled. And so now he could reset the lab, for example, or he could click on a radius like 0.5 millimeters or 0.25, and that selects a different pipette. There you go, he selected 0.5. And so we're basically exploring how it is to work with different pipette radiuses and then generating the drop weight on the scale, 20 drops of ethanol. Is ethanol drinkable, or do they have two types, one that's not drinkable? Anybody?
Is it denatured somehow?
That's what I would hope. I mean, in real life.
Otherwise, you're going to lose some of it, maybe.
Well, that or they'd be having too much fun. Yeah, probably not. Not drinkable. All right, so the idea was to simulate hands-on surface chemistry experiments in the height of the pandemic, and also kind of show that it's possible for this to be done. And later they found another alternative to this kind of virtual lab, and they're in the process of comparing which one is more effective, which ones do the students find the most satisfying to use, et cetera, et cetera. And at this point, I'd be happy to put this in some place like Chemistry World, where different people, high school or undergraduate chemistry instructors, could bring students in and play with it. It's not being particularly used much right now, so and I have 6 set up for the University of Hong Kong, but I don't know if they're actively using it or not. So yeah, if anybody's interested, let's see, I can put my email address. Brant@knutzen.se or brantknutzen@gmail.com. Either one of those will work. If you know somebody, give them my email address, and I'd be happy to donate this to somebody who wants to use it on their world, or I could come set it up for them. But I'd love for it to
yeah, that'd be cool. I think that I can't speak for the owner there, but I think that in Chemistry World might be
Oh, good.
interested in something like that.
I'd be delighted to set it up as an open educational resource in Second Life. And I'd like to see more of that, frankly, where stuff is put up, made available to anybody who wants to use it. But then you got to get word out to all the chemistry teachers who would like to use it but have never used Second Life, or at least is unaware of Chemistry World.
Okay,
Well, I don't
well, I
know.
took a photo of all of this so that with the email addresses and stuff so that I can send that to them so they know what they're looking at.
Great. And then I also have a video. Here's the link. It was also
I
in.
was looking at the YouTube one before. This is it here.
Yeah, and it's on my thing that's for this VWBPE.org conference. So it shows, see this video for more info, and it just starts it at a point. I'm kind of reviewing all the different things I produced over the years in Second Life, and this is one of the more recent ones, so it's near the end of that video. But Electra, thank you for capturing this, and hopefully someone will find it useful. And if I can help, I'd be happy to. All right, any questions? Thanks again to Sheila and Dee Dee and Vic for stepping up.
Where did you learn the programming for this?
I didn't do much programming. I have done prior developments like the fire safety one where I set up the lab and then the developer specialized with the movements and the synthetic fire and things like that. But I would build the entire lab. But this particular lab is pretty much all the programming is done by him. He's trying to remember what his avatar name was. I haven't talked to him in a couple of years.
Brant, so this is somebody in Second Life who did the
development coding, yeah, and I'm trying to remember. I should have looked that up earlier. Oi, cat. I haven't talked to him for a while. Oh, yeah, I can't remember. It's been a couple of years and my memory is not what it used to. But I will be happy, Phil, to set you up with his contact information when I can remember it. He's on my Facebook somewhere. I'm just blanking on his name or his avatar name at this point.
Yeah, I was looking at who made it. It had the creator name. Sheila's got that on there also.
Oh, good. Yeah, under edit, of course. Yeah, Sias Saranan. That's it. It's kind of a hard name to remember. That's my best excuse I could come up with.
Yeah.
But he's a great...
Sounds Finnish.
Yeah, he really likes that little raccoon in Guardians of the Galaxy, so he uses that. And I'm sorry, I'm blanking on his name. I'm sure I'll feel foolish if I can find it. Don Bickley. Don Bickley was his name. He works at a university up in Alaska, in Valdez, and I can put his email address if you want. If you guys are looking for a good developer, let me see if I can pull that right there. Yeah, I assume this email still works. Thank you for helping with pulling it off the actual device, the product he made. But yeah, I played the systems analyst working with the faculty and then narrowing it down to what kind of experiments and what's the layout going to be. And then he did the developing. That's his email address. He's definitely an underutilized talent. He spends half his time manning a help desk, you know, and people can't log in. And yet he can produce this kind of amazing development in the virtual world. Like many of us, we've waited for years for VR to take off. That's why I double majored 20 years ago in psychology and computer science, was thinking it'd be good for AI, but it takes forever for VR to kick in, particularly Second Life. So much potential, yet so underutilized. Yeah, I'm sure a lot of us have waited with high hopes for a long time, and VR is slowly becoming more popular, but AI is just exploding. But nonetheless, VR is still pretty underutilized, often because of nausea, right? If any of you have ever put on a mask, a goggle, and then been in a world and just got sick to your stomach, hence the our preference for the desktop VR, as Val likes to say. Oh, there she is. Val's here. Doesn't need a Adirondack chair. Well, any questions about the lab equipment?
Yeah, but it's nice that you can do something like this where anyone anywhere in the world that you're working with can experiment like this. Most people wouldn't have the money or anything else to get a scale of that sensitivity or be able to do something like this. This is great.
Yes, that's a great point. Hong Kong has lots of money, but they don't tend to do much original work in the technical field. They do a lot of derivative. They take something that someone else has done and they figure out a way to make it better. But that they tend to throw a lot of money at their teaching development grants, which is what this was, funded by at the University of Hong Kong, which is the big university, the big dog in Hong Kong, one of the top universities, if not the top, in all of Asia, as far as research goes. Yeah, I agree. 2.5 VR, as they say, 2.5D or desktop VR is, I think, way more manageable, particularly with students now that pretty much every student's laptop can run Second Life. Maybe not a Chromebook, but if anybody has a good Windows laptop, I agree. And 2 screens are even better, or a wraparound screen. But so this is basically 6 different experiments all packaged in one. Didi or Vic, if you could click on Quit Lab. Oh, and I finally built in a timeout. Well, we built in a timeout because students weren't quitting, they were just leaving it open and it would sit there for ages. And no one could use it because no one had successfully quit out. Didi, click again on Quit Lab. Probably have to click, there you go. And it checks for prior labs. And there was a fair amount of debugging involved with placement. And when we got some of these labs too close to each other, that was a problem because they'd start cross-talking. So they have to be spaced out somewhat, not too close to each other. And it just sits there like this. And you put it on a table, like you can see I made this little bench, and I had a much more realistic looking bench in the labs that I set up for University of Hong Kong. But any kind of table that's long enough, and it will just set up the experiment and run. It uses all temporary prims. I think it's only, what was it, 4, land impact of 4. And then when it's running, it does a temporary prims of under 50, like 46, 47. So it has very little land impact. It would slow down the processor on a server a little bit because it's, setting up things. So if you had like 50 of these labs, you might overwhelm your server if they all were being operated simultaneously. All right, well, that's pretty much it for my presentation. Phil, I'm eager to set it up in Chemistry World if Science Circle wants that. I'd be happy to contribute it to the greater good. And thank you, Sheila, for contributing, participating. And Dee Dee, thank you. Anybody else have any questions? It's good to see you, Val. Been a long time. Yeah, you did get to class a little late. All right. Well, that's all pretty much I have to say in my presentation. Thank you for coming. And Electra, thank you for doing transcription. And Stevie for her valuable help getting me going here at this venue. All righty. Well, on with the show. Off to the next of the presentation.